Hi folks, this is Nat, and this is going to be your video lesson on identifying and using line and angle relationships. We talked in our last video lesson about a couple angle relationships, and what we're mostly going to be talking about today are the different ways that lines can cross or not cross and generally interact with each other, and then some of the angle relationships that are created by lines that intersect. So starting off, we're going to go through some of the most basic line relationships. Some of these you'll probably have heard of, some of them might be new to you. And we'll start off with the idea of intersecting lines. You're probably familiar with this, but the basic idea of lines intersecting is it's anytime two lines cross. And one of the things that's really important about intersecting lines is that they share a single point. For example, the one that we see here, we have these two lines crossing at that point, and we could name that point if we wanted, but these are intersecting lines. And we care about intersecting lines just generally because it's a common thing that we see lines do, but also because, as we learned in our previous lesson, it creates lots of interesting angle relationships. So for example, we could talk about how these intersecting lines here have a couple sets of vertical angles. Or we might talk about how these intersecting lines create a couple sets of supplementary angles that make 180 degrees. But we've already covered that, so we're not going to spend a whole bunch of time on that. There is another more specific type of intersecting line, so this would fall into the category of intersecting line, and that would be what are called perpendicular lines. We say that lines are perpendicular to each other when they intersect specifically at a 90-degree angle. So if you look at the lines I just drew here, not only do they intersect at whatever point this is, but they also intersect at a 90-degree angle. And because of the way supplementary angles work, because one of these angles is 90 degrees, it actually ends up being that every angle measurement on the inside of this perpendicular intersection is also 90 degrees. So we end up with 4 90-degree angles at a perpendicular intersection. So it's kind of nice to know if I see two lines intersecting and I know that one of the angles created is 90 degrees, all the angles created are going to be 90 degrees. There are also lines that never intersect at all, and these are going to be called parallel lines a lot of the time, not always. So for example, if I draw two lines that have the exact same trajectory, they never get closer or further away from one another, we would call those lines parallel. And parallel lines live on the same plane and never intersect. And just like we sometimes see that box in the corner for perpendicular lines that lets us know that those lines cross at a 90-degree angle, we've got a special symbol we'll frequently see for parallel lines, which is a little arrow on the line, or sometimes if there's more than one, it'll be two arrows. But those will be there in the middle to indicate that those lines are parallel, so that we don't have to wonder, well, are they parallel or are they just really close to being parallel? There are also lines that never intersect that are not parallel, and they're a little harder to sort of understand, but they're called skew lines. So when you hear the idea that two lines don't intersect, they're not necessarily parallel, and this has to do with three-dimensional space. Let me show you what I mean. Imagine that this is a cube sitting in three-dimensional space. I'm going to draw some lines along some of the edges of this cube. I'm going to start by doing this one right here, and then I'm going to draw a line along this one right here. Didn't quite line up correctly. Let's try again. If we imagine these lines in three-dimensional space, hopefully we recognize that they're actually never going to intersect with one another, but it's not because they're parallel. It's because they actually occupy two separate planes. They're never going to cross because in three-dimensional space they don't share the same plane. The line on the right here occupies this general plane, whereas the line on the left, we might say occupies, I don't know, this plane over here. So because they don't share a plane, they're never going to intersect one another. So generally speaking, skew lines are lines that don't intersect because they are on different planes. Parallel lines are on the same plane and they still never intersect, and that's really the difference between the two. That gets us to our last line relationship that we're going to talk about today, and it's the idea of a transversal. A transversal is what happens when you have a pair of parallel lines that are intersected by a third line. So that third line, the one that intersects your parallel lines, is the actual transversal. So a transversal is a line that intersects a pair of parallel lines, or more than a pair. It could be 3 or 4. The reason we care about a transversal is because it has an interesting set of angle relationships that come along with it. If you think about it, this kind of makes sense. When we imagine this line cutting across our first parallel line, it creates a set of 4 angles. And when it goes on and connects with that next set of parallel lines, because the parallel lines are moving in exactly the same direction, the angle set created at the second intersection will be exactly the same as the angle set created at the first intersection. For example, this angle will be the same as this angle. Now, because of the way vertical angles work, there's a couple sets of vertical angles here, and I know that this first angle is going to be the same as this one. And again, because of the way transversals work, I know that that next angle is going to be the same as that one. So I've actually got 4 identical angles created by that transversal because it's cutting across parallel lines at the exact same angles. Similarly, the other side of the angles are going to be the same too. So I've got this angle will be the same as this angle, and again, because of the way vertical angles work, this one will be the same as that one, and this one will be the same as that one. So because of the transversal, what are created are actually 8 separate angles, but there's only 2 measurements in all of them. And the neat thing about that is if I know one angle measurement for the entire set, I can figure out all the others because of the way vertical and supplementary angles work. For example, if I knew that this angle here was going to be 60 degrees, I know that all the other angles I've labeled pink will also be 60 degrees. And because these 60-degree angles are all supplementary with the orange angles, because of the line intersections, the missing angle is going to be 120 degrees, and it's going to be 120 degrees at every single intersection. So by knowing that single 60-degree measurement, I was able to figure out every other angle measurement on this transversal parallel line intersection. And that's the reason we care about these. You learn a lot of information from a very little amount of information when you have a transversal. And these relationships have actually been named. There are what we call opposite exterior angles. And that's an angle relationship that refers to the relationship between the parallel lines and the transversal. Opposite refers to opposite sides of the transversal. Exterior refers to the outside of the parallel line. So if I want to think about it this way, here's the exterior. Here's the interior of my parallel lines between them. And then again, the exterior again. So we have 2 exteriors and 1 interior. And when I talk about opposite exterior angles, what I'm talking about are angles that are on the opposite sides of the transversal but exterior to both parallel lines. For example, this 120-degree angle would be opposite exterior with this other 120-degree angle, because they're both on the exterior of the parallel lines and they're on opposite sides of the transversal. Similarly, these 60-degree angles are the same. 60, 60. Those are opposite exterior angles as well. The opposite of an opposite exterior angle is an opposite interior angle. And when you talk about an opposite interior angle, you're talking about the inside of the parallel lines, again, opposite sides of the transversal. So here's a 60-degree angle here, and opposite side of the transversal, but inside the parallel lines is that other 60 degrees. Same deal, 120. Opposite side of the opposite side of the transversal, interior of the parallel lines, there's your other 120. The reason we care about these things and have names for them is because when we talk about either type, those angles are always congruent. So opposite exterior angles are always congruent, and opposite interior angles are always congruent as well. Here's a quick example of how we can put some of that stuff together and learn a lot of information from what may look like very little information. So here I've got two parallel lines, and I can tell that they're parallel because of these little arrow symbols happening. So I know a couple things. Any line that crosses them, in fact both these lines, are transversals. In addition, because I see this line crossing this line and this line at a 90-degree angle, I know that these lines are all perpendicular to each other. So there's a bunch of stuff I can kind of start filling in and knowing right away. Knowing what I know about perpendicular lines, I know this is 90 and this is 90 because they're marked, but I also know that every other angle along our perpendicular intersections are also 90. So I know all 8 of those angles. Down here, I see that this is a 67-degree angle, and I see this is a transversal crossing the two parallel lines. So I know that, for example, if this is 67 here, the opposite exterior angle will also be 67. So 67 degrees there. Because both these 67s are vertical with the ones across from them, those will be 67. And because I notice that this is a supplementary set, I know that they'll have to add up to 180. So my missing angle measurement is going to be 113 degrees. Again, vertical over here, 113 degrees. And then also I've got this idea of opposite interior angles. 113 is opposite and interior with this angle over here. So once again, that will be 113. And vertical again, 113. So with very little information originally, I've actually found every single angle in this drawing. And that's the reason that we really like all of these line relationships. And here are your practice problems for the lesson. For 2 of these, 1 and 2, you need to draw the thing that's being described. If you'd like to do that in GeoGebra, you could. For number 3, find the measurement of angle ABC. And keep in mind the only thing we know for that one is that this angle measurement here is 20 degrees. So find the missing angle measurement ABC. All right, good luck.